So what are we doing tonight?
Reviewing for final.
Okay. Must have next week, huh? Or are they Friday? I mean, are you off next week, or do you go to school Monday, Tuesday, Wednesday?
I'm off next week. I have math finals tomorrow.
Ah, okay. Let's do it. Tell me where can you verbalize these?
Yeah.
Okay. Where do we want to start?
Solve the polynomial inequality.
Okay.
X plus 2. X plus 5.
Times x plus 5?
Yeah. Times x plus 8 is greater than or equal to 0.
Okay. Are you familiar with the line chart method?
I don't think so.
You probably are. You maybe just aren't familiar with that name. What are our critical points here?
-2, -5, -8.
If we draw out a number graph and mark those points on it, and I'm purposefully not putting 0 on there, the way we're going to solve this problem is we're going to check, in other words, any number I pick that's left of -8 will give me the sign of the product of these three things. For example, pick an x that's -9, plug it in, and the only thing we care about is the sign. We don't really care what the number result is. So when x is -9, what's the sign of this term here? Plus or minus?
Negative.
What's the sign of this term?
Negative.
What's the sign of this term?
Negative.
So all three of them multiplied together are what?
Negative.
Okay, so I can put negatives. In other words, no matter what number I plug in to the left of -8, it's still always going to produce 3 negatives. Now pick a number between -8 and -5.
6, -6.
Okay. What is this term when x is -6? Is it positive or negative?
Negative.
This term
Negative.
and this term. Negative times negative is positive. So everything in this region is positive. Pick a number between -2 and -5.
-3.
Okay. Makes this one negative, makes this one positive, and this one positive. What's the product of these three? Positive or negative?
Negative.
Okay. Finally, a number to the right of -2. What's a nice, easy one to do?
-1.
How about 0? 0 is the easiest one because now we got plus, plus, plus. That means anything to the right of -2 produces a positive answer. Now, to answer their question, we look on our line chart. Where is it positive? In other words, where is everything greater than or equal to 0? It's when x is greater than or equal to -8 or less than or equal to -5, or when x is greater than or equal to -2. There's my solution.
So how would you put that on a interval notation?
Interval notation, it would be, bracket, because it's less than or equal. So bracket -8 to -5, also bracket, in combination with bracket -2, comma, infinity, parentheses, because parentheses always go next to infinities. So this is the interval notation answer.
Okay.
Okay? And this technique becomes particularly valuable if you have rational functions. In other words, if I had x plus 2 divided by x plus 5 or something, then it really becomes valuable. I could probably figure out this solution without using this technique, I guess. I'm not sure I could, but this technique is so wonderful that just think of this technique whenever you see an inequality where you have something greater than linear on one side of the equation. In other words, the moment you have something greater than linear, meaning quadratic or cubic, then you need to use this technique. Do you have another one?
This one's different.
Okay.
Completely factor the polynomial x cubed minus x squared minus 8x plus 12.
Plus 12?
Yeah.
And they give you no other information?
No.
Did I write it correctly?
Yep.
Okay. So we're going to have to use the rational factor theorem here, which is going to turn this into at least a 10-minute problem. We can at least get started. I don't know if you want to spend that much of your session on this problem, but let's get started and you can tell me whether you want to continue working on this problem or not. What are all of our, if there is a rational 0, and we can find it, then we'll have a linear factor and we'll be left with a quadratic, and we can certainly handle the quadratic, right? So the difficulty with this problem is finding one solution. Once you find one solution, you can easily find the other two. So the rational factor theorem says that if there is a rational solution, its numerator must be a factor of 12, and its denominator must be a factor of 1, the coefficient of the x cubed term. Tell me all of the factors of 12.
Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12.
Since the possible denominators are just plus or minus 1, that makes our possible rational factors these 12 numbers. There's 2 solutions there, 2 there. In other words, there are 12 possible rational solutions. How do we find one of them?
Don't you do the synthetic division?
Yeah, they call it synthetic substitution, but it's really synthetic division. And what we're looking for is to come up with a 0 right here. If we can get a 0 remainder, we'll have a solution. In other words, there's 2 theorems that are at play here. There's the rational factor theorem, which is what says your numerator has to be factor of the constant and your denominator has to be a factor of the coefficient. And then there is, it's only a factor if it produces a 0 remainder. So we have to, by trial and error, try each of these numbers until we find one that works. The way I do it is I always start with, I do it based on arithmetic. The easiest one to try is that one. If that doesn't work, I'm going to try minus 1 next. If that doesn't work, I'm going to try plus 2 and then minus 2 and so forth and so on. So do the synthetic substitution for me here.
1, and then 1, and 0, and 0, negative 8.
No 0. I'm not going to get a 0 there. That's not a solution. Let's try -1. It's amazing that this is how you have to do these problems, but it's the only one we... In other words, it would be nice if they had a cubic formula like they have a quadratic formula, but they don't. Nobody's ever figured one out.
And -1.
Yeah, once I know you know how to do it, I don't mind doing it. That's not a solution. Now, have you had upper and lower bounds yet?
Like on the calculator?
No. When you're dealing with the rational factor theorem and synthetic division, there is a rule that if all of the bottom is positive numbers, then that is an upper bound. If all of the results alternate signs, then it is a lower bound. And that can help things, because if I discover that 1 is an upper bound, then I'm not going to have to try +2, +3, +4, +6, or +12. I haven't found an upper bound yet. The first time through that I didn't notice, but I'm pretty sure that we didn't have that. Okay, so let's see. We tried -1, it didn't work either. Now let's try 2. I'll go ahead and do it. Follow along with me. Make sure I don't make a mistake. Aha! We got liftoff. What are my factors now that I know for this polynomial? I can now break it up into a linear factor and a quadratic, and I may or may not be able to factor the quadratic. I'm going to be able to, but let's do that in a second step. What's the linear factor?
X minus 2.
Quadratic?
X squared plus 1 x minus 6.
And then factor that for me.
3x minus 2. X minus 2
X
squared.
plus 3 times x minus 2. That produces that middle term. So what are my solutions?
2 and 3.
2 and -3. In other words, if x plus 3 is a factor, and this could be 0, then x would be equal to -3. In other words, all three of these multiplied together are equal to 0. So the way we solve it is we set each one equal to 0. Set that equal to 0, that equal to 0, that equal to 0, and it produces only two solutions. One of them is multiplicity 2. The other is multiplicity of 1. Have you studied multiplicity? Do you know what I mean when I say that?
Yeah.
Okay. So that's the way you do those kind of problems. And if you haven't had upper and lower bound, we don't need to talk about that. If you don't know about upper and lower bound, then it's completely trial and error. And you just start with some of these and try them until you find a 0. And it's theoretically possible that you could try all 12 answers and not get a 0. In other words, you don't have to have a rational solution. You could have imaginary and irrational solutions. All right, what else you got?
Factor 3x to the 6 plus 6x to the 5th minus 48x to the 4th minus 96 to the x. 96x to the 3rd.
Okay, what's the first thing I can do here? In other words, this is different than most polynomials in that there's no constant, right? So if there's no constant, then it's a greatest common factor problem. What's the greatest common factor?
3x cubed.
What do I have left over?
X cubed plus 2x squared minus 40, minus,
Like that.
okay, yeah.
Okay. So now that that's equal to 0, I know that either x is 0 or this whole cubic is 0. Well, guess what I have to do to factor this cubic? There's only two methods that I know of for solving a cubic. One is by grouping, but this doesn't lend itself to grouping. In other words, for something to be... What'd you say?
Is it the same thing as the last one?
It is, only worse, because 32 has a lot more factors than 12 did.
Oh, then I know this process.
So we can do that if you like, or probably it's not going to be advisable to spend 15 minutes on the same problem we just did.
Yeah, the other way one would be different.
Especially if you have a lot of review material. So I would suggest we go on. If you want to come back to this and redo it, we can. And we're going to do it exactly like we did the other one. We're going to find all of our possible rational factors, and then we're just going to start trying them until we get one that works. So let's go on to a different type question. And like I said, if we have time and you want to come back to that, we can. Now, hold on one second. Is it possible that you're supposed to do this on a calculator?
No, it says no calculator.
Okay, that's what I thought. In other words, this looks like a rational factor theorem problem. If it was a calculator problem, they'd probably make it even tougher by putting a number in front of there. All right, so what else do you have? I'll look at.
F of x.
Boy, okay, f of x. Okay, go ahead.
Equals x minus 1 over x plus 3 x minus 5.
Times x minus 5?
Yeah.
Like that?
Yeah.
And what are we supposed to do? Graph it? Find vertical and horizontal asymptotes? Stuff like that? Domain, range, x-intercepts, y-intercepts, all of that?
Not the domain and range, just x-intercept, y-intercept, flat, slant, horizontal, vertical.
Okay. Let's start with the easiest thing, vertical asymptotes. That also gives you the best way of starting out your graph.
Negative 3 and 5.
Okay. Negative 3. It's right there. 5 is right there. It's a horizontal asymptote.
There is none?
No, there is one.
1?
It's actually 0. In other words, if we multiply these together, we would end up with x in the numerator and x squared in the denominator, plus other stuff. But in terms of the horizontal asymptote, this is the only thing that matters. If the degree in the denominator is bigger than the degree in the numerator, then the horizontal asymptote is always y equals 0. If it's the same, then the horizontal asymptote is the ratio of their coefficients. So it would be 1. If they're the same and you have something like that, The horizontal asymptote is at 2/3. So the first thing you have to determine is the highest degree in the denominator, the numerator, or are they equal? If it's in the denominator, then automatically the asymptote is y = 0. So here is the basic structure of our graph. What else do they want besides to graph it?
X and Y intercept.
Okay. What is the y-intercept? That's the easiest one to figure out, because all we have to do is substitute 0 for x. So what's the y-intercept?
1/15.
Okay, so it goes through that point right there, our graph does, 0, 1/15. The x-intercept.
1.
Good. If that's 1/15, then that's probably 1 over there. That's 5. So my scale is off a little bit, but you get the picture. We know our graph has to go through those 2 points. These are always hyperbolic in nature. In other words, a hyperbolic graph looks like this. This is not 1/x, but it's close. It's hyperbolic in nature, and its graph is going to look something like, if I have 2 asymptotes right there and a horizontal asymptote, then it probably is going to be like this, like that, and like that. Okay? That's almost certainly what our graph's going to look like. But you never know whether you're in this quadrant up here or this quadrant down there. So if I really want to graph this thing properly, I have to know that answer. How am I going to figure out whether my graph looks like this, or maybe it looks like this and the other end is up there? How can I figure that out?
You can plug in a value greater than 5 into x.
Okay, let's plug in 6. When I plug in 6 for x, what do I get?
5/9.
Which is above or below the x-axis?
Above.
Okay, that tells me that this is the correct picture. In other words, I know that I'm in this quadrant up here, and that it's going to be asymptotic to my vertical asymptote and my horizontal asymptote. And then I know that immediately in between my asymptotes, it has to go through those 2 points. And these things almost always look like this, unless they don't cross the x-axis, and then they just look like an upside-down U. But we know it crosses the x-axis because we have an x-intercept and we have a y-intercept above the x-axis. And then it has to come out down here. In other words, it goes up to infinity here, comes out on the other side of the vertical asymptote from negative infinity, goes up to positive infinity, comes out on the other side of the vertical asymptote at negative infinity, and then of course that is asymptotic to both asymptotes also. So there's our graph. We got everything. What else is there anything we didn't get that they needed?
No.
Okay. The domain and range, we could certainly figure out from looking at the graph, right?
Mm-hmm.
What's the range?
Negative infinity
to
positive infinity?
Uh-huh. The entire range we can see from just the part that's in between the vertical asymptotes. In other words, that part right there goes from negative infinity on the y-axis to positive infinity. And that's the range. What's the domain, even though they didn't ask for it?
Parentheses, -3.
Start from the far left.
5.
If we're talking domain, we're talking the allowable values that x can be. So I want to start from negative infinity.
Negative infinity to negative.
And negative.
And then -3 to 5. And then 5 to 2.
There you go. All right. What else?
Solve the equation 2 over x minus 2 plus 3 over x plus 3 equals 4 over x squared plus x minus 6.
When you see an equation like this, and there's a quadratic in it, that looks like it can be factored, factor. Now, there's two ways we can solve this equation. We can add these two fractions, finding a common denominator, and doing so, and then going from there. But there's a technique that I really am particularly fond of, where in one step, we can get rid of all denominators that are in this equation. What do I have to multiply every term by?
X minus 2 and x plus 3?
Yeah. So when I multiply this term, what am I left with?
2x plus 3?
2x plus 6. Remember, always put your parentheses in there. In other words, this is going to be 2 times x plus 3 over x minus 2 times x plus 3. Right? In other words, this term right here is the same as this term right here, but only with the parentheses is it the same. Well, now when I remove the parentheses, this becomes 2x plus 6. About this term here, what do you get?
3x minus 6.
And finally, on the right side,
4.
and you can see why I love this as a first step. Because it takes this complicated equation and turns it into a really simple thing with no fractions in it. So now we got 5x equals 4, x equals 4/5. Okay? Now, if you didn't notice that first step, well, we can certainly solve it in the traditional way, which would be to find a common denominator, which is going to be x minus 2 times x plus 3.
Well, they told us don't do that.
They told you not to do it this way?
Yeah, because it's so complicated. It just says
Yeah.
multiply the denominator.
Okay, good. So they like that first step also. Right?
Yeah.
Okay. I have a little bit of difficulty understanding what you're saying sometimes. I think it's my connection is a little poor. What else?
Find all solutions satisfying the equation square root over 2x plus 3 equals 5.
Like that?
Yep.
Okay. What's my first step? I'm trying to isolate x.
Square both sides.
What's the next line?
2x plus 3 equals 25.
Which makes 2x equal 22, x equal 11. Now, make sure whenever you have equations that have a radical in them, they are ripe for extraneous solutions. Now, we only got one solution here, so it's not likely to be extraneous. And if we plug it in, it works. We got the square root of 25 equals 5. But if this turned into a quadratic and I had two solutions, usually one of them is not correct. So whenever you see a radical sign, always check your solutions. You don't generally need to if you have a straightforward polynomial, but if you have radical signs, absolute value signs, or logs in the equation, all three of them lend themselves greatly to extraneous solutions. What else?
Find the difference quotient for the function f of x equals 3x squared minus 7x.
Do what? Find what?
The difference quotient for the function, and it's 7x.
Like that?
Yeah.
They want the difference quotient.
Yeah.
Not sure what they mean.
Neither do I.
What could they be talking about? I can factor an x out. In other words, that's equal to x times 3x minus 7.
Oh, it's one of those f of x plus h minus f of x over h problems.
Ah. Okay. If this is f of x, and they want to know what f of x plus h is? Okay. The difference quotient. Okay, sorry. I'm with you now. The difference quotient is f of x plus h minus f of x, all divided by h. So they want us to apply that to this function. So first of all, what's f of x plus h?
3x plus h squared minus 7x plus h minus 3x squared minus 7x.
This was the whole function, right? 3x squared minus 7x?
Yeah, so like it's f of x plus h minus f of x over h.
Right. So let's first of all figure out what f of x plus h is. And then we'll subtract f of x, and then we'll put it all over h. But it's best to do these one step at a time. So what is f of x plus h? Let's simplify this. Square that.
X squared plus sh plus h squared.
Plus 2xh plus h squared. Okay, minus 7x minus 7h. Putting it all together, we have 3x squared plus 6x h plus 3h squared minus 7x minus 7h. So that's what f of x plus h is. And we need to subtract from that f of x, which is 3x squared minus 7x. And it's in parentheses because that's f of x. Okay? You with me so far?
Mm-hmm.
Okay, these always go away. The only terms that stay are the terms that have h in them. Every time, no matter what the function is. Every term that doesn't have h is going to disappear. So what are we left with in the numerator? In other words, what is f of x plus h minus f of x equal to? Well, it looks like 6xh plus 3h squared minus 7h. Right?
Mm-hmm.
And I'm to divide all of that by h. And now I can factor out the h's. In other words, I can simplify this. I can cross that h out with that, one of those, and that. So my final answer is 6x plus 3h minus 7. That is the difference quotient. Any questions about that?
No. Okay, this one I don't understand. Simplify the expression minus 3r 1/2 to the half power t to the third power
I'm sorry, what?
t to the third power, 1/3 power. And all of that is squared times 5r 1/4 power t
You're saying T or P?
t
P as in Paul?
t as in t.
What was the power on the T?
3/4
Okay.
and then parentheses.
That's it?
Yeah.
Okay. What are we going to do first?
Square the first one.
In other words, let's simplify this. We're going to still have parentheses because the parentheses now are so that we can multiply it by that term there. What's the number going to be? Inside,
9.
after we square it, becomes 9, right? Minus 3 times minus 3. And the 2 does operate on the minus 3. It's inside the parentheses. That 2 operates on everything inside the parentheses. What's the exponent on the r become?
1/4?
Just 1. It's 2 times 1/2. In other words, you always multiply the exponents when you're doing a double exponentiation like this. So it's just r to the 1, and then what's the exponent on t?
I'm not sure.
What's 2 times 1/3? 2 times 1/3 is 2/3. Okay? Now, we're going to do it variable by variable, starting with the numbers. What's the final number?
45.
What's the exponent on the r variable? What's r to the 1 power times r to the 1/4 power?
5/4.
5/4, exactly. We add. In other words, when you're multiplying same base, you add the exponents. And finally, the t, we have to add 2/3 and 3/4. So that would be 8/12 plus 9/12, 17/12. Here's your answer. The key thing to remember on these problems is that, like I said, when you're doing, I call this double exponentiation. I don't think that's what mathematicians call it, but I do it just because it seems to make sense. In other words, we're exponentiating t and then we're squaring the whole thing. So whenever you're doing double exponentiation, multiply your exponents. When you are multiplying variables, in other words, if I'm multiplying x to the 3rd times x to the 4th, I'm going to add the exponents. But if I've got x to the 3rd being exponentiated to the 4th, I'm going to multiply them. Those are the two most important rules that apply to that last problem. Okay?
Find the domain of the function f of x equals square root 3x minus 10.
Like that?
Yep.
And they want the domain?
Yep.
Okay. How am I going to get the domain?
Set it equal to 0.
Yeah. Set what's inside the radical equal to 0. I don't want to set the whole thing equal to 0. But what I do know is that you can't take the square root of negative numbers. Therefore, whatever is inside the radical has to be 0 or greater. So the way I solve it is by taking that and making it greater than or equal to 0, which makes x greater than or equal to 10/3. There's your domain. And it matters not how complicated it is. In other words, if I gave you something like this, that was inside the radical, then you just take that whole thing and make it greater than or equal to 0 and solve it. And then you'd have to use a line chart to do that. In other words, in order to solve that inequality, I'd find my critical points, I'd do the line chart, come up with the intervals where it was greater than 0, greater than or equal to 0. What else?
Find f of g of x if f of x equals 2x over x plus 3 and g of x equals 6 over 5x.
If I said to you, what is f of 2, how would you do it?
Plug in 2 for x.
Okay. So if I say f of g of x, I'm asking you what is f of 6 over 5x, right?
Mm-hmm.
So how would you do that?
Plug that into.
Okay, so we now have what?
Well, 12.
Okay, let's plug it in parentheses and then simplify, I think is the best way to do it. I think it's a mistake to try to do the simplification at the same time you're plugging it in, especially when it's a complicated function like this. In other words, I'm really fond of doing this. That always is going to be my first step. Not to even do any simplification at all to begin with. Okay, this isn't a satisfactory answer, so what can I do next?
Multiply.
Okay, well, yeah, I could certainly multiply the 2 out. Make that 12, okay. Now what?
Multiply 5x on the top and bottom.
What we need to do is we need to take the denominator, which is a binomial term, and turn it into a single term. How can I do that? I need to find a common denominator for the bottom.
Well, would it make sense just to multiply 5x on both sides so you can cancel it on the numerator and the denominator?
You have to multiply this by 5x also. In other words, what you say makes a lot of sense, and it would be wonderful if I could just cancel these 5x's out, but I can't, because this 3 gets in the way. So if I wanted to multiply top and bottom by 5x, I could do that. That's not a bad way to solve this problem. That becomes the new top, and the new bottom becomes this. And I guess that is what we are going to end up with, regardless of how we do it. Yeah, let me just go through the way I would normally do this. I actually kind of like the way you did it. I've never thought to do it that way. So the way I would do it would be 12 over 5x, still in the top. In the bottom, I would find a common denominator, which would be 5x. And I've got 6 plus 15x over the 5x. You see what I'm doing here? I'm adding those two together. Now I got 5x and 5x, and I can cancel them, leaving the answer 12 over 6 plus 15x. But I love what you did. You solved it in one step. I had never thought to do that in one step. Just make sure that when you do that step, you multiply. In other words, you can't just cancel out the 5x's. You have to multiply every term, top and bottom, by 5x to get to this term over here. Okay. Is that all they wanted was fog on that one? They didn't want goth? G of f of x?
No.
Okay.
If f of x equals x plus 2 cubed to find the inverse of x.
X plus 2 cubed, like this?
Yeah.
Okay. How do we find inverses of functions? It's a two-step process.
So you set f of x becomes y, and it's y equals x plus 2 cubed.
Okay.
And the y switch. So it's
Okay,
x
so
equals y.
the two steps that I was referring to are switch the variables and solve for y. So first thing, I always switch the variables first. You can do it in either order, but I think it makes more sense to do it in this order. Okay, how do I solve that for y?
Take the cube root on both sides.
Okay, so now I have x to the 1/3 equals y plus 2. And y equals x to the 1/3 minus 2. There's your inverse. Now, simple functions are very straightforward. Switch the variables and solve for y. Tell me if you've had something like this. What was the number? I think it's that. No, maybe it's 1. It's 1. Do you know how to do this one? And is this something that you might have to know how to do?
I think so. I know I've done ones that be like 3x plus x over like x minus 1 and try to find the inverse of it.
Let's see if I've got this right or not. This is actually very complicated to do. Let me make sure that I got the right thing here. Let's see, is that the right factor? That gives me plus 2x. That's what I want to do there. All right. So, if you tried to find the inverse on this, go ahead. First step?
3y squared plus 2y minus 1.
Now it gets fun. Now solve that for y.
Plus 1 on both sides.
Huh?
Add 1 on both sides?
No? Can't solve it for y. You can, but it's very, very tricky to solve it for y.
Well, wasn't it like you try to find the common factor? And the common factor would be y.
Well, if this was equal to 0, then I could apply the quadratic formula to it. Right? I mean, if we have a quadratic and we're trying to factor it, the quadratic formula is always there. But you can only apply it if it's equal to 0. So in order to solve this for y, I have to treat x like a constant. And if this is completely new territory for you, say so and we won't cover it. We're not probably going to have time anyway. But it's so clever I wanted to mention it. In other words, if I want 0 on that side, I got to subtract x from both sides, and now I have to treat that like c. In other words, if I'm now to solve this quadratic, a is 3, b is 2, and c is minus 1 minus x. Plug all that into the quadratic formula and you get your inverse. And it's a function of x, as it should be. But this is the only time I can think of in math where you can pretend x is a constant and lump it together with the other constant, and this now becomes c. You know, the A, B, and C of a quadratic formula. And that's the way you'd solve for y. Pretty tricky, but pretty clever too. All right. You have one more quick one we can do? I do have another session I have to get to, but I was a couple minutes late, so.
No, it's fine.
No? Are you good to go?
Yeah.
Well, good luck on your final. So you must be off next week, huh? All next week?
Yeah.
Yeah. I don't have you down for next week, do I? Actually, I did have you down for Wednesday. So you want me to cancel that Wednesday session?
Yeah.
Let me just make sure that that doesn't lose you for the rest of them. Okay. Mina, I will talk to you in a couple weeks.
All right. Thank you.
Have a good Thanksgiving. Bye-bye.